Welcome to today's webinar. I'm Gang Tao, CTO and co-founder of Timeplus. Today, I'm super excited to be hosting this webinar. I'm joined by Bryan Wood, solution engineer from Redpanda. Together with Bryan, we too will explore how we can modernize your real-time data architecture from Kafka and ksqlDB to Redpanda and Timeplus. I'd like to introduce you, Bryan and Bryan Wood. Hi, Bryan. Do you want to maybe have a quick introduction about yourself to our audience today?
Yeah, real quick, thank you so much to the Time Plus team for having me on here. Really excited to cover all the material about that we're about to cover. My name is Bryan Wood. I'm a solution engineer at Redpanda. I spend a lot of time in the field finding good solutions for our customers. I've been in tech for 20 years, kind of in just about every role you can imagine. So, like I said, really looking forward to covering some of the details around uh, what we're going to cover in this webinar today.
Yeah, yeah, thanks, Bryan. Yeah, I'm super happy to have you here today with me. And a little bit about myself. I'm CTO co-founder of Timeplus. I've been working in the software engineer for like more than 20 years. And I'm really super fans of AI, BI, data visualization stuff. And yeah, if you have such related topic, feel free to ping me and I'm happy to share with you. So let's go to into the content of today. So I would like to start with this data stream platform architecture as the starting point. So you may ask, hey, why today's topic is about real time? So why you're talking about streaming, right? So that's not a mistake. We are talking about streaming because streaming is actually one of the most effective way to make your data in the real time, right? So if you want the data, why you wanted such a real-time data platform? Probably because you want to make like a automatic real-time decisions. You want to have real-time report or dashboard for analytic. You want to take actions in real time triggered by your event, or you really want to do some real-time AI and ML, like real-time anomaly detection or real-time recommendations. All these need to be supported by this real-time streaming data architecture, right? There's a choice. So in this architecture, you have a lot of different data sources, like some of them are high frequency, real-time one, like sensors, logs, metrics. Some of them might be slow changing data, but also you want to make them streaming like application data or your social media data. And so in the middle, we can see that the key stage of this data processing pipeline is actually to start with a data ingestion, or in a traditional, well, we call it like integration platform. And you can choose Redpanda Connect or Kafka Connect. And then you send all your data in a streaming storage or something like a streaming even bot or something, where all your stream data is there. You can choose Redpanda, Kafka, or Parsa. And then with all these data, you want to process these data, these events in real time. There are a lot of choice. Traditional, we have some open source one like Flink, Spark, or K-Stream. These are all like pure stream processing. But there are other options like more like a database style, ksqlDB, Materialize, or Rising Wave. And one of them is actually also time path, right? That's what we are going to talk about today. And after you process your data, you will send those data to some destination. It could be your OLAP database like ClickHouse. It can be your data lake, Snowflake, or Iceberg, or even S3. So, and then you get all your real-time data somewhere. It can be used to you can query them, you can make dashboard or something like that. So today we are going to talk about, there are a lot of architecture choice. You can choose the different tools that can support this, right? But what we are talking about today is that actually with your Redpanda and Timeplus together, can solve all your need for streaming ingestion, streaming storage, and stream processing capabilities. These are the choice you should have, and that's we are talking about why and how you can do that. Something I want to like share is actually Timeplus and Redpanda together. We share a lot of common design principles. Even at the very early stage when we start Timeplus, we take a close eye at this project, the Redpanda, and also Redpanda team. Actually, we found a lot of commonality between these two product and two teams. Here's some design that both products share, like both Redpanda and Timeplus are designed for performance. Both of these two products actually built on top of C++, so provide very high performance by those native optimizations. And also, both Redpanda and Timeplus are designed for simplicity, right? So actually, Redpanda is my favorite tools I use in my daily works. No matter for POC, for like demo, for some internal development, I use Redpanda quite a lot because both Redpanda and Timeplus are single binary. There's no extra dependency. It's super easy to set up. And both Redpanda and Timeplus are designed for developers. For example, the Redpanda has fully compatible Kafka API. If you're using Kafka, you don't have to change any of your existing code, right? It's fully compatible. And Timeplus is SQL provides SQL interface and a lot of SDKs. So that means you don't have to learn anything as a developer or data engineer. You don't have to learn anything else. You already be familiar with SQL, and you can use this knowledge to process your real-time data, right? And last but not least, both Redpanda and Timeplus are designed for production for scalability, right? Redpanda has very good scalability design. It's very super easy to set up a Redpanda cluster, and similar like at Timeplus. This is also benefit from the single binary design, right? If you have single binary, it makes the scalable much easier, right? So both Timeplus and Redpanda has very good scalability design. So that's something that's commonly shared by these two products. That's why we propose if you are looking for a modernized data architecture with real-time data streaming support, Redpanda and Timeplus is a good combination for you. Okay, so next I'm going to hand over to Brad, and Brad will give us an introduction about Redpanda.
Hey, thank you so much. Um, Super excited to talk about Redpanda. I think what I'm going to do is, trying to get to a bottom line up front as we're, talking through a couple of complicated concepts and things like that, just when it comes to streaming and connectors and all the things that you might care about. One of the things to think about Redpanda, one of the ways to think about Redpanda, as Gang had alluded to before, is from the outside, we look like a Kafka cluster. Our Kafka API is fully compatible. We have a schema registry. We have all the things that your Kafka cluster, is going to have. It's going to be simpler, better, cheaper, faster, more features, things like that. But on the outside, we have the Kafka API. And if you're kind of just thinking about this in high level terms, how am I, okay, fine, if you guys are going to give me a streaming platform, how are we going to get that into our infrastructure? There's a great many ways, right? If you just want to try it out, there's some great pathways for you. If you want to deploy it yourself because you have an air-gapped environment or something like that, we have really great ways for you to manage it very simply and very hands-off. And obviously, we also have great many cloud solutions, right? So, as you can see on the right, we've got a BYOC architecture where essentially we can care for and feed your Redpanda cluster inside of your cloud account in AWS, GCP, and Azure. We can also host it for you, and you can peer with us or private link with us. And we also have great serverless options where if you want to be co-tenant in a cluster that we're taking care of, there's some scaling and some cost benefits there. We can scale to zero, kind of a solution. So kind of on the outside, when you're thinking about where to put Redpanda or how are you going to put it there, I'm pretty sure that we can meet you where you're at. We've got, like I said, a pretty full, robust set of self-hosted tools as well, and also the community edition, right? You can get started, you can use it and deploy it and be successful on it without talking to us at all. And we have great, tools for you to do that. We've got Helm charts and Ansible playbooks and things like that. Um, so let's move on real quick to the just the underlying architecture that Gang also talked about before is one of the great things we have in common is we're written in C++. Single binary architecture is some great phrasing for kind of synonymous with simplicity. When you're deploying things, containerizing things, packaging things up, the more parts and pieces you have, the more complicated it is, the harder it is to take care of. And as you can see from the little picture here on the left, uh, for anybody who's ever had to take care of a Kafka cluster, it's a large distributed system in and of itself that is focused on performance and real-time storage and delivery of data. And there is a lot to it. I run across regularly in my day-to-day life full-time Kafka admins, right? That's what they do. They're familiar with schema registries and kraft and brokers and things like that. And so one of the things that we do is we take away that operational burden. We make it a lot simpler, and we give you really just the Redpanda broker, and that replaces all of the other kind of parts and pieces you need to take care of. Each one is its own schema registry. There is no external system for coordination like kraft or Zookeeper. You don't need cruise control to balance your partitions, things like that, right? It's a much simpler experience. Uh, let's move along to the next slide. Uh, yeah, and then kind of on the outside, right? So the inside, we look like a Kafka cluster. Uh, right around this time last year, we acquired a company called Benthos, and we've rebranded it as Red Panda Connect and invested heavily into it. And now we have a really, really simple solution, single binary architecture as well, for you to, in a very ergonomic way, connect all of your data sources up and deliver data into or subscribe to data and deliver data out of your Red Panda cluster. We've got a whole bunch of great ways to connect all kinds of services together, relational databases and pretty much anything you can think of, as well as all of the normal Kafka SDKs and drivers and libraries and platforms and things like that.
Yeah, okay. Yeah, thank you, Brian. Yeah, actually, I would like to mention one thing. Actually, Timeplus Enterprise also integrate Redpanda Connect to leverage the Redpanda Connect to do the data onboarding. So beside those main data sources like Kafka, Redpanda, Pulsar, we actually support all these Redpanda Connect way to ingest your data.
Hmm.
Yeah, thanks, Brian. So
Yeah.
so next, I'll be talking about the time pass. If you Some of you may not know time pass or may already know. Well, time pass is a unified real-time pipeline that for your analytics, your telemetry, or AI stuff. So time pass simplified both stateful and stately stream processing. So it's a single binary like we mentioned, similar like Redpanda, so you can easily run, deploy, manage time tasks. And also it's actually similar like a database to provide a SQL interface. So you can do all your stream processing and do all your pipeline management in the SQL. I will be demoing some of those as follow-up. So, but generally, a key difference of time pass compared to the other stream processor like Flink, Spark, Kstream, is actually Timeplus also have its own storage. That means Timeplus can store all the intermediate query result, so you can reuse this query stuff. And also Timeplus provide very good exploration. You can query your stream, your table, your MV, where using the SQL quite convenient. I will show that. And there are a lot of customers that is using TimePass. There's like a financial trading services in a video game, and in e-commerce and a lot of other use cases. Next, I'm going to give a quick demo about how Redpanda and Timeplus work together to solve real customer issues. So in this case, it's actually the IIoT real-time processing system. So the customer has a lot of IoT devices that located in all of different regions. So there's a lot of devices in different sites. And so what we provide previously, the customer actually was using Confluent and ksqlDB, and later on they actually migrate to Redpanda and Timeplus. So Redpanda is your like mentioned, provide the data ingestion and data streaming. So there are two main data sources. One is like this external stream created in Timeplus is actually the device that all those IoT devices reporting telemetry data in real time. Quite a lot of those events in a huge throughput reported, and also there's application data is actually all the device information, like device metadata. So where this device name, firmware versions, site, and some of those data are managed in the MySQL database, right? So that's actually the very typical use case that you have your high volume, high throughput, highly change fast real-time data, and you have your application data, which also we take it as stream, but it's slow changing, right? So what the customer need is actually they need to join these two streams, like enhance enrichment. So that means we need to fill in those information from the application database to the real-time telemetry, right? So in the time task, we just create a materials view to read the data from the table, this MySQL data, into a mutable stream. This mutable stream is similar like a ksqlDB table. So and then we have this real-time stream. So we just join the table with stream. So we enrich the result, and this is another materials view that do the enrichment is actually a joining. So after joining, we do a aggregation because customer want to know what's the like a 50 minutes telemetry aggregation result or what's the 1 hour aggregation. So they do the tumble window based aggregation. So this show the end-to-end flow. And then eventually, Timeplus will send those data back to Redpanda topic so that customer can consume them, maybe send to another database or maybe they direct query those data. But that's the overall data process pipeline, right? So one thing I'd like to mention is in a Timeplus, for those external stream, Timeplus actually directly query them. You can use SQL to query the data in the Kafka, in the Redpanda topic, without moving the data. You don't have to move the data from Timeplus, from the Redpanda to Timeplus. And but some of them actually Timeplus does persist the data. For example, in this case, the mutable stream for the data table, for the materials view, for the drawing result, we actually keep them in Timeplus. So that's why I draw a storage icon here. That's the key difference compared of Timeplus different than the other stream processor tools. We do store your data, so you can use a historical query later to query this data, or you can just reuse this intermediate result in other data processing pipeline. We will show you how Timeplus and Redpanda work together to give you the this pipeline. And we go to the data lineage. You can see this is exactly the same data lineage I show you in my previous slides. There are two streams. One is the device, the real-time telemetry, read from Redpanda topic here, like device event. And the other one is actually this is the external stream that we created, and the other one is the MySQL device, the CDC application database data, the table data, right? What the target is we want to join these two streams. And this is the Redpanda console UI. You can see actually the three topics. Actually, the Redpanda console UI is my favorite tools because I think it is one of the best Kafka managed UI you can have. I like it very much, and I also saw the customer use it regularly. You can see we actually can query those external stream directly without moving the data. All the data is still in Redpanda topic, but you can use Timeplus to directly query them. And we do multiple. We move the data from the external stream for the MySQL data to a multiple stream, and then we actually join the two streams using a joining. So here for the multiple stream is similar like it has the key, right? We actually merge the data by key, so that means you always get the latest result of the data after you. For example, in the application database, either you add a new item, you update the item, we actually always get the latest result of that key. So that will make sure when you enrich your real-time stream, you always get the latest information to enrich your data. Here's the multiple stream result. It's a data table. I call it a table, but it's actually in Timeplus, it's actually a multiple stream. And we join these two streams using materials view. So you can see this materials view will join in the two streams. One is the real-time stream, the telemetry data from reported from device. The other is the MySQL database table from the CDC from your database, MySQL database. So we join these two streams, so we get the real-time enrichment. We fill in the device name because this device name it will not be reported by the telemetry, but we can look up it from the MySQL database. And the last type of this pipeline is actually we do an aggregation. In this case, we do a tumbling window aggregation. So we know for each different site what the total event reported in the last minute, right? So this is just a highly simplified pipeline. In the real customer case, there's a lot of different telemetries to be monitored. So they monitor like 50 minutes telemetry or 1 hour telemetry. So they all do this aggregation, time window based aggregation. And then we actually send data back to another topic of Kafka. This derived topic contains the information that customer is looking for. Yeah. That is the overall workflow of this pipeline. You can for the external streaming similarly, we actually can query them as well. So all the data is actually in the Redpanda topic, but customer can directly query them, explore them, right? So that's what we have for this pipeline. And finally, you can see we actually have all these resources actually is managed in SQL. You can see everything, the external stream, everything is just a simple SQL. You see, we create the external stream, create the mutable stream, create the MV to move the data, and we create the MV to join the data, and also create the MV to to aggregate the data and send out back to Redpanda topics. Next, I'm going to talk about some of those why the Redpanda and Timeplus work together, provide some of those benefits. So the first one I would like to talk about is the performance and efficiency. Actually, there's a blog we talk about. We do an internal test. At that time, I think we were looking for streaming storage that can provide ultra low latency. The latency here means, for example, in this case, you have a data source and and you send data, you use Timeplus external stream to query this event. So what's the end-to-end latency here means when the event generated and sent to Kafka topic to the time that the query return the result, emit the result, right? So during the test, we compare the performance, the latency performance between Redpanda and Kafka, right? So and you can see the improvement is significant, right? So like the P90 latency for Kafka is about 50, and with Redpanda it's only like a 6 millisecond. That's a big improvement for the performance. So that's why I think at that time we we think Redpanda is the best combo with Timeplus. If a customer is looking for a super low latency implementations or architecture choice, we always propose that Redpanda is the best one to use. Next one, I'm going to share this Timeplus and Redpanda together, provide some operational simplicity. This is also the same customer case that previously customer is running MySQL, Confluent, Kafka, and ksqlDB. So I found there's a lot of, when I review with the customer how their architecture looks like, I found there's a lot of such topics like they just read data, they read data from Kafka topic and do some repartition and create another topic. As you know that with ksqlDB, actually any of those new streams or tables, they actually create actual Kafka topics. And they do this repartition. Why they do such kind of repartition for each topic? Actually, because with ksqlDB, if you want to join into streams, they have to be co-partitioned with a key. So they move the same key in the same partition so they can do the joining effectively. But that's obviously a waste because actually you you just duplicate data because when you create an repartition topic, you actually copy data from A to B only because you want to join in the stream. You have to do this data replications. This actually wastes quite a lot of resources, not only in the storage of the actual topic, but also you do the repartition, which means there's a network, there's computing. So yeah, after move to Redpanda and Timeplus, with Timeplus query, there's no such limitation. You have to do the co-partition. So there's no, the customer any don't need those top creators repartition topics, right? So that means they saved quite a lot of computing network and storage resources. I would like to say more than 50% reduction in the cost. The last, I want to say, Redpanda and Timeplus together, we provide very powerful analytic capabilities. So internally, we do this like next mark based benchmark. You can see we actually test all the next mark queries use it for benchmark for the latency, for the end-to-end test. You actually see Timeplus perform much better compared to either Flink or ksqlDB. It's actually 2 times or even 50 times faster compared to. But not only in the performance, actually there's one thing I would like to mention is actually if you are using ksqlDB, you can see actually there's a 22 benchmark queries and only like 12 cases were supported by ksqlDB. So most of the cases that you cannot even write those queries in ksqlDB. And actually Timeplus support most of them. That's why I think, I'd like to say, Timeplus and Redpanda provide such a powerful analytic capabilities. Okay, so next I'm going to hand over to Bryan again because yeah, we talk about data streaming architecture. We talk about Timeplus with Redpanda provide a better, no matter the performance, simplicity, or the capabilities. And you would like to ask, what if I want to migrate from my existing stack, from Kafka, ksql to the Redpanda and Timeplus? I hand over to Bryan, talk about this migration guidelines.
Yeah, thanks, gang. One thing I would like to double down to on what you were covering previously is whenever I run across ksql in the field, there is always a massive partition sprawl, and those aren't necessarily free. Like they eat up resources on whatever your Kafka solution is. They eat up memory, they slow things down, and ultimately, your cluster's resources as they degrade, it impacts your performance, and obviously is super complicated. So, I'm very, very delighted, right, when we get a chance to reduce those things and increase the performance of a customer's cluster. And usually you lower their TCO by quite a significant amount too. Um, Sorry, moving along to the migrating. This is the core of what we do, right? We go around and we find customers with large Kafka implementations and we offer them better features, better management, better solutions, and things like that, usually for a much lower TCO. And so when we kick off with a customer, we've not been successful with them until we've migrated. It's our kind of one of our core competencies as a company, since we're going around trying to find existing solutions, right? Not green. Obviously, greenfield solutions are great too, but if you're migrating from a Kafka solution, we have a great many resources for you. The Redpanda Migrator lives within that connectivity framework that I was talking about before. It'll migrate your schema registries, it'll migrate your topics. One of the incumbent solutions out there is Mirror Maker. And really, Redpanda Migrator, you should give it a look, right? They're not completely feature complete, right? Either way, but Redpanda Migrator has a lot of nice tools on either side, right? So should make that experience much better. We have a migration checklist and a migration guide and streamcasts and professional service or architects and things like that to help our customers migrate. We're extremely good at it. So always feel free to hit me up or hit us up on our website or whatever, or look at the guide we have here. But just know that there's a whole bunch of resources available to help assist in that. And then also, Gang, if you want to cover the ksqlDB migration.
Sure. So, yeah, Brian, do you want to talk a little bit about the Redpanda Connect and
Yeah.
with Kafka Connect? Yeah, maybe the audience will ask what's the difference. Yeah.
Yeah, totally. That's a really good point. Thank you. So Kafka Connect, if you've ran into it in the field before, it's its own architecture, and then it's got plugins that you have to manage to connect things to different things, as well as a concept of tasks that you feed this cluster that's running that then go and run these pipeline or these migration jobs. Redpanda Connect is completely different. It's a single binary. All of the connectors are rolled up into that little Go binary, and you configure it with a single YAML file, right? And an example of that YAML file is here. You can do some very, very basic, like single message transform kind of things. And then on the input and the output, right, you can specify what your inputs and outputs are. This is where that migrator tool lives, right? It's the exact same architecture. You would just define, here's my source cluster, here's my destination cluster, here's my schema registries on either side, and it's going to magically pick up all your data and move it so that you can have a much better experience as you're migrating your producers and consumers over.
Yeah, yeah, thanks, Brian. So yeah, last I would like to talk a little bit about the the concept level. If you want to migrate your KCQ resources to Redpanda, to the Timeplus, actually, it's very straightforward. Most of the migration is super simple. With ksqlDB, if you have a stream, you have table, you can migrate to Timeplus stream and Timeplus mutable stream, like what I already showed in the demo. And KCQ doesn't have a clearly concept called materials view, but actually when you write such SQL like create the stream as select something, you create a materials view in ksqlDB, and in Timeplus we just create a materials view as select as your queries. And all the temporal window in KCQ is some keyword tumble hopping session. And in Timeplus, we use those table functions called the tumble hop sessions. For the query mode, in KCQ, you append an image change and you go to the push mode. So all your query result will be pushed to the client in the real time. But in Timeplus, we have two mode. By default, it's the push mode, the real-time mode. All your query will continuously push data to you. And if you add table function to your stream, you actually turn to the historical query. So in that case, you actually just query the data in our historical store, similar like any other database. And then finally, if you have customer-defined functions, like in ksqlDB, you read them in Java, and Timeplus provide JavaScript, Python, or remote UDF, which you can migrate your existing complex business logic to using the new JavaScript base or Python base. Okay, so I think we run a little bit over time. So let me do a quick wrap up. So thanks, Brian, joining me. So we introduced both Redpanda and Timeplus, and this combination has a lot of design synergies. Like we share a lot of common design principle. So this combination give you better performance, better simplicities, and also it's a powerful tools you can use to fulfill your daily real-time analytic works. Yeah, thanks everybody. Thanks, Brand. And let me check. We still have maybe a little bit time to do a quick Q&A sessions. So the first question is, what's the best way to get started using both Redpanda and Timeplus together? Yeah, maybe I can hand over to Brian. Brian, you can talk about Redpanda, then I can add information about the Timeplus.
Yeah, awesome. Thanks. I think the two easiest ways are going to be we have a really great compose file with a bunch of stuff all wired up for you if you want to like get your hands on it and just try it out. We're super happy to sponsor and facilitate evaluations of our cloud products and things like that. If you go and sign up, we can give you some free credits on our serverless setup. So lots of different avenues to try us out. Definitely feel free to reach out and like I said, we're happy to sponsor evaluations and things like that.
Yeah, thanks. Yeah, I think the combination of the time-lapse and Redpanda, like Brian mentioned, can the with time-lapse is super easy. There's no dependency, so if you just run the time-lapse and you if you have your Redpanda broker address, you can create a external stream without moving data directly run the query, right? That's a good starting point. And of course, I think there's a lot of options. You can, yeah, if you want to know more, please just contact Brian or myself. So we will love to provide support. Yeah. And the other question is about the uh, the time plus view about the new real-time Spark streaming features. Yeah, it's super excited about that features. The Spark streaming has a new mode called real-time mode. That's also what yeah, we are happy that because in the past, Spark streaming is like in a macro batch mode, which means the latency is not super good. Um, with this real-time mode, it greatly improved the latency. That proves that the latency stuff, the real-time stuff is critical, and customers probably will ask them. That's why Spark added support. And yeah, I think one thing to mention is that it's a good starting point for Spark. Still, I think it's still the difference compared to time plus streaming and Spark streaming is still like a uh, first is the complexity. If you add real-time mode, if you run real-time mode with Spark streaming, it's still kind of complex because it's actually not designed with real-time. It's actually adding those real-time processing to the macro batch. You're still kind of complex. Also from the resource wide, no matter Flink, Spark, or even Kafka, they're Java stack and Java stack had those limitation with the JVM for the resource utilization. So that's why Redpanda and Timeplus use C++, provides much better resource utilizations, right? And also from operational wise, if you want to operate Spark, it's a little bit complex, like mentioned. The single binary architecture makes Redpanda and Timeplus super easy to use. You don't have to worry about any dependency stuff. But when I use either Flink or Spark, it's kind of hard because you there's a lot of dependency. If you want to use the new features, you have to import a new jar dependency. Those jar libraries sometimes are not compatible with your main versions or not compatible with your Java versions. So it's super complex to manage. Yeah. But yes, that is good. I think we are very happy to see that the community, whatever the community or other stream process vendor, they move to the real-time directions. Yeah, I think we are running pretty out of time, and I think we won't have any other questions. But if you still have questions, feel free to reach out. And thanks again. Thanks for the brand to join today's webinar. I'm super happy and to have you here with us.
Yeah, thanks for having me. This has been a blast.
Mm. Okay. Thank you, everybody. And yeah, like mentioned, we will send our recordings. And if you have more questions, let us know. Thank you.